All right, in this video, we're going to take a look at some examples of solving triangles using the law of sines. So, in our last video, we saw what the law of sines is, and also where it comes from. So, example one, we're going to solve the triangle below, given that measure of angle A is 120 degrees, the length of side A is 7, and the measure of angle B is 45 degrees. Round your answer to one decimal place. Oftentimes, you may not be given a diagram, so if you're not, just sketch one, and it doesn't even have to look pretty or beautiful or even accurate, just as long as you have your side lengths opposite the angle of the same name. So round your answer to one decimal place. So this is an example of an angle side triangle. In other words, you're given two angle measurements and the side length that's not in between them. So when you're given two angle measurements and a side length, whether the side length's between them or not, that's going to mean to use the law of sines. And as we'll explain in the law of cosines video, there's a nice way that things are set up where you won't be able to solve this using law of cosines, so you can only solve it using law of sines. So as far as this triangle goes, we have to find the measure of angle C, the length of side C, and the length of side B, and we're going to round to one decimal place when we need to. So first up, let's use the fact that the angles of a triangle add up to 180 degrees, which means angle C is going to be 180 degrees minus 120 degrees minus 45 degrees, which means angle C is 15 degrees. So we'll label it in the picture. Now from here, we have to find the length of side B and the length of side C. It really doesn't matter which one we find first. So we'll find B first. So we have the sine of 120 degrees over 7, so we know angle A, we know the length of side A. So we can set up sine of 120 degrees over 7 equals sine of 45 degrees over the length of side B, or sine of 45 over B. So when we cross multiply, we get B times the sine of 120 equals 7 times the sine of 45. And then to get the measure of the length of side B, just divide both sides by the sine of 120. And you can type this into your calculator. Again, I want you to round to one decimal place. So you get approximately 5.7 for B. All right, now we're pretty much going to do the same thing for side C. I do want to advise you, though, when working with law of sines and working with law of cosines, try if you can to always use what you're given first before you use approximations that you found. So that means rather than do sine of 15 degrees over C equals a sine of 45 over 5.7, what we're going to do instead is do sine of 120 over 7 again equals a sine of 15 degrees over C. The reason why is this 5.7 is an approximation, and if at all possible, you want to avoid using approximations and estimates and roundings in your problem, because what will happen is your actual answer for C would be off a little bit from what it should be. So just go with the information you're told up front, and you really won't have to worry too much. Cross multiply here, we get C times the sine of 120 degrees equals 7 times the sine of 15 degrees. Divide both sides by the sine of 120, which, if you'll notice, the only difference between what we entered into our calculator in the last step and what we have in our calculator now is we had sine of 45 before, now we have sine of 15. Everything else is the same. So we might be able to save a little time by just changing the 45 degrees to 15 degrees. And when we do that, we get C is about 2.1. So I'm not going to grade your pictures. I do want you to consolidate all of your final answers into one space. So here we have the measure of angle C is 15 degrees, the length of side B is about 5.7, and the length of side C is about 2.1. So this right here is what I want to see. You can use the picture to help. Speaking of, there's a concept in geometry that says the larger the angle of a triangle, the longer the side opposite that angle. It's why the hypotenuse has to be the longest side of a right triangle. We can use that result to check to make sure our answers make sense. So first, our smallest angle is 15 degrees. That is across from the shortest of the three sides, which is good. Our biggest angle is 120 degrees. That's across from the longest of the three sides, which is also good, because if those two conditions hold, then the angle in the middle is going to be across from the side length that's in the middle. 5.1 is between 2.1 and 7, as 45 degrees is between 15 degrees and 120 degrees. So we can use that to help us check to make sure we didn't maybe miscalculate anything. All right, example 2, solve the triangle given measure of angle A is 85 degrees, B is 30, C is about 5.25, so we can just sketch this out. This one's an angle side angle, which we're going to use law of sines on, because if you know two angles and a side, doesn't matter which side it is, you're going to be using law of sines. So once again, we can use triangle angle sum to get the measure of angle C, which is 65 degrees. So now we're going to have to use the sine of 65 over 5.25 to get the length of A and to get the length of B. So we'll start with A because it's alphabetically first. Sine of 65 degrees over 5.25 equals the sine of 85 degrees over A. Cross multiply and then divide by the sine of 65 degrees. And you get about 5.8 for the length of side A, which is good because 85 is bigger than 65, which means 5.8 needs to be bigger than 5.25. Finally, to get the length of B, we can set up the sine of 65 degrees over 5.25 equals the sine of 30 degrees over B. When we cross multiply and divide, we end up with B is about 2.9. So our measure of angle C is 65 degrees, the length of side A is about 5.8, and the length of side B is about 2.9. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.